Hello everyone, I'm Dr. Brano Ermias, and I'm here to welcome you back to our series on stability of excavated rock slopes in the field. This is episode 4, and in this episode we will dive into crucial formulas that are used to calculate Q slope value and also to determine the steepest slope angle. We are going to see two formulas in this episode. Also, I will highlight key insights for students, engineers, geologists, contractors, consultants, and other organizations and professionals. Therefore, stay tuned to the end of the video, and also please don't forget to like and subscribe to the channel. Today we are also going to break down the essentials of essential parameters for the Q slope equation. Also, I will show you, or I will give you a practical field techniques for assessing and gathering the parameters used in Q slope equations. Once you gather the parameters, then you will insert the values of these parameters in the equation, and the Q value will be obtained. Once you get the Q value, then you can be able to calculate the steepest slope angle. Therefore, let's get started with today's episode. Episode 4 begins with the 9 parameters of Q slope that we discussed in episode 3.
So these are the 9 factors considered in determination of Q slope value. Since Q slope value is determined based on Q system, remember Q system, so most of the parameters used in Q system are maintained in Q slope determination also. The formula for estimating Q slope value is given as Q slope is equal to RQD over joint state number times joint roughness number over joint alteration number times O factor, that is orientation factor of this ratio, times environmental and geological factors divided by strength reduction factor of the slope. That means when you say strength reduction factor of the slope, there are 3 strength reduction factors. That are strength reduction factor A, B, and C. So the largest or of the 3 will be considered for calculation. So since there are 9 parameters considered in Q slope determination or ratings, there are 9 tables for each rating. There is a table. Therefore, while we are giving the rating for each parameter, we will utilize these 9 tables 1 to 9 present the Q slope rating is used in equation above. So there is a table for RQD, there is a rating table for JN, there is a rating table for JR, JA, and for the O factor also for JYs, and for strength reduction factor of the slope also. There are rating tables, so we will consult the table while we are giving ratings for each factors, and finally we will get the Q slope value. After obtaining the Q slope value, by inserting the ratings for RQD for each 9 parameters in this equation, we will get the Q slope value. After obtaining this Q slope value, the next equation 2 we use is the optimal or steepest slope angle is equal to 20 times logarithm of Q slope value plus 65. Using this equation, we will be able to determine the steepest slope angle for that specific cut slope. Okay, so we can determine the optimum or the steepest slope of the cutting for specific geological and structural condition by using these 2 equations. This will help us to give Q slope value, and this equation will help us to determine the steepest slope angle using the Q slope value as input in this equation. Okay. Now we will discuss the 9 parameters or the tables 1 to 9, one by one. This is a formula used to calculate Q slope, and now I'm going to show you how to determine each of these components of the formula actually during excavation on site. Let us start from the first parameter in the Q slope, that is RQD. RQD is defined as the summation of rock core pieces greater than 10 centimeter divided by total core run times 100% according to Dre 1963. But this is for core samples. But during excavation of slope cutting, during slope cutting, we do not conduct core drilling. Therefore, we have to follow another way of determining RQD, and this is the method we use to calculate RQD on site from the excavated rock slope using the Hutchinson and Deirdre 1996 method. What you need on site is only a ruler, scaled rod, or a measuring tape of 2 meters long. If you have that, then you go to the excavated rock slope and put it on the excavated rock slope, and you will just measure the intact rocks with between the discontinuities, the lengths or the spacing of the between the discontinuities, or the lengths of the intact rock between the discontinuities, and you will record those lengths, so spacing is greater than 10 centimeter, and then you will sum up all those that are greater than 10 centimeter and divide it with 200, that is 2 meter. That is times 100 will be the RQD value. Calculate RQD value for this dimension, for this dimension, for this dimension, and for this dimension. And then when you take the average of this, you will get the RQD value for the slope that is similar to the RQD value that you get from core samples according to Dre 1963. The RQD value you get, for example, you get here is 61%, and when the RQD value is 61%, the rock quality is described as fair quality. So fair quality rock. Like this, you can implement this on your project site and determine RQD easily like this. The next parameter is joint set number. For joint set number determination, I have taken this picture from the authors of Q slope method. I have selected this picture to just help me show you how to determine the joint set, the JN, that is the joint set number. What we need to do is, for example, assume this is the slope that we are dealing with. Then we want to determine the JN number. In order to determine JN number, first we have to determine the number of joint sets manifested on this slope. So I determined this as first sets of joints and the most critical joints, and assumed it as joint sets A, and those joints that are aligned in this direction I assigned them as joint set C, and the joints aligned in this direction as joint set B. So joint set A are the most critical for stability, joint B as the second most critical, and joint C as the least critical. And the other joints maybe the random joints are also random joints can be identified. Therefore, for this slope, I assumed the number of joint sets is 3 joint sets plus random joint. Once you have done this on the slope, then you will go to the joint set number rating value. You will get the rating value from this table. This is table 2, joint set number. Ratings are given here. If the joint sets are 3 joint sets plus random joints, then the JN rating will be 12. So we will take 12. RQD is 61, JN is 12. Therefore, RQD over JN means 61 over 12.
In our next episode, we will inquire further into the practical field techniques of assessing and gathering the Q slope parameters. Thank you very much for joining today's discussion, and please do not forget to like and subscribe for our upcoming episodes. Your engagement helps us bring you more valuable content. Till next time, stay safe and knowledgeable out there.